fine for screenshot, fine for writing on your iPad. So that one is totally up to all of you. You decide what works best for you. Okay. Number two, yesterday's class was amazing. Many of you were super engaging, right? So continue to engage with me. Ken, if okay, please type okay in the chat, right? Just continue to talk to me so that we can move on, right? And then we can faster complete. The whole syllabus is super long. Okay, so continuously engage with me so that we can make this session fun together. Now, last but not the least, yesterday I got a few people very rowdy, okay, unkind to one another. So can we ensure that today is a kind environment, right, whereby all of us can learn well and be focused, productive, and enjoy the whole session? Okay, so over here, those that are unkind, okay, my team members are gonna send you out to the waiting room. Okay, last warning, okay. So can you please type kind in the chat? Can we please be nice to one another, right? If you make mistakes, all that is perfectly fine. Right, so just answer questions, okay? All that is totally fine one, okay? Okay, so yeah, last warning to those that are spamming weird stuff in the chat. Okay, beautiful. I love AMath. Okay, so I'm curious, right? Yesterday some of you came for the EMath class. Have you all received the cheat sheet for those that have tagged and shared? Have you all received the stuff already? Okay, no. Okay, so some of yes, right? Okay. Okay, so those that haven't received one, right, just go and bum us or just DM us, okay, to remind us. Okay, but over here, right, yesterday I've shared that as long as you just share some kind words and share the things that we are doing, then we will give you. So similarly over here today, right, who wants AMath cheat sheet now? Yesterday was EMath, right? Today was AMath. Okay, so same thing, right? Okay, not now lah. Okay, but similar to yesterday, right? For those that wants the AMath cheat sheet, right? Just do us a mini favor, right? For those that have yet to follow us, please follow us on our IG. And then throughout the entire session, right, in the next 1 to 2 hours, you can just tag and share whatever that you're learning, whether it's beneficial, what is your greatest learning experience throughout the session. Just tag us. And then subsequently later on, you'll just fill up a mini form so that we will know who to contact and send you over the cheat sheet. Okay, so yesterday, people are talking about very nice stuff, sharing their experiences, right, taking pictures, etc. Okay, so for those that are going to tag us later on, we will send you over the AMath cheat sheet. Okay, can? Okay, so that's all that I want to share with all of you over here. Okay, so Raj, can you help to send over the PDF? Okay, are we all ready to begin? If you're ready, please type ready in the chat. Okay, my team member will send over the slides that we're going to use today. And we're going to start in less than a minute time. Okay, so I just wait for all of you to just transfer to your iPad if you want to transfer. Okay, so you all can just take a look at the chat. Okay, don't spam now. Rosh send the PDF again so that the rest can see the notes. Okay, and then you all can transfer to your soft copy. Okay, let's take 30 seconds to do that, and then we're going to start in just a bit. Okay, those that are ready to begin, am I still sick? Yeah, I'm still sick. I feel like it got worse. Okay, those that are ready to begin, can you please type okay in the chat? Okay, we're gonna start. Okay, wait for a few more people. 5 more seconds, sure. Okay, let's wait for a few more people. Okay. Oh, okay. Last 10 seconds, then we will start. Okay, let us begin. Now we are gonna, time travel back to the first chapter that we learned in school, right, since Sec 3. And the first topic that we're going to look at, right, going back all the way to Sec 3 last year in January, we start off with quadratic functions, okay? And the first thing that we want to quickly recap on is on completing the square. So over here in completing the square, the most important rule that I want to share is that the coefficient of x squared must be positive and 1. So for those that I have, all of you are taking E-math, right? Usually E-math is pretty chill, right? The coefficient of x squared is usually going to be positive 1. But in A-math, right, please highlight, okay, and especially go and prepare questions where the coefficient of x squared is not positive 1. Then that is where you have to go and factorize and then complete the square accordingly from there. Okay, so that's the most important thing that you got to take note over here. And more importantly, right, recently the syllabus just kind of like, they just refine and change a little. So what we are more particular interested with is applications of completing the square. Okay, so how many of you remember in prelims, right? Completing the square is tested in sort of like an application format. Anyone? Okay, if yes, please type me in the chat. Right, your completing the square is like, there's someone diving or jumping or shooting right? So there's sort of like a curve. Okay, so this is something that we want to take note, right? Because in our syllabus, they just recently just added in this application over here. So I want to quickly just walk through with you a simple question, okay, that deals with completing the square. So in the next page, take a look over here. Tom owns a company that sells bicycle helmets, and then the profits follow this particular equation. Determine whether Tom's company can achieve a profit of $65,000. Okay, so after we complete the square, right, take note, we have to go and factorize first. I want to do a quick sketch, and then we're going to explore what are the important points to take note in this graph. Okay, so let's say we have a graph that looks like this. Okay, just draw a set face graph, okay, because the coefficient is negative. Now, I want to ask you, right, over here, the y-intercept, what is the value of y-intercept? Okay, please type in the chat. What is the value of y-intercept? Okay, well done, everyone. Not 64,000. Okay, the y-intercept is over here, negative 7,500. Okay, I want you all to go into the story, right? Immerse yourself into the storyline. What does it mean over here? What does the y-intercept means in this context? What does negative 7,500 means in the story, right? Let's say you're Tom, you want to sell bicycle helmet. Net loss, losing money. Okay, so please take note, right? This is, yes, the starting cost, right? You can write down, this is kind of like the fixed cost, the starting cost, whereby he pays for the factory, the materials, the staff, etc. That's where he haven't sell any helmet, right? But he already incurred this amount. So this is sort of like his starting cost. Okay. Now thereafter, as he start producing more and more helmets, you'll realize that he reached a point whereby the profit is 0. So what can we call this? A word start with B, whereby the profit is $0. James, well done. Okay, so this is where he break even, right? So if he produce this amount of helmets, then the profit will be $0. There is a break even cost. Okay, so this is the break even. Now, as we continue moving up the curve, you'll reach this maximum point. Okay, can you please type in the chat? What is the maximum value? What is the maximum value? So we look at the curve, right? The maximum profit is $64,500. And that is where he produced how many helmets? Okay, and that's where he produced how many helmets? 2,400. Okay, 2,400. So to do well in completing a square application, very simple. You just need to immerse yourself into the storyline, understand that, right? What is the y-intercept means? What does the maximum point means? What does the root means? Then more or less, you all should be able to do well in this segment. Okay, it's a free 5 marks for many of us over here. Easy so far? If easy, please type easy in the chat. Okay, that's all they're gonna test. Okay, so of course over here, they cannot reach 65,000 lah, because the max is 64,500. Okay, so 95% off you easier. Okay, so I've given another example of a question, right, whereby they relate to a bridge. Then you have the tower, you have the cable, the minimum point, the y-intercept. So you can see that this is another type of question that you need to prepare for in this segment, okay, under completing the square. And that's all they can test. All right, so I just put one question for you all to practice lah. Okay. Amazing. Okay, let's continue. So the next topic that we're gonna follow through is on quadratic inequalities. So under quadratic inequality, so just take note of the direction of the sign. So on the left side, when we are solving the graph is larger or less than 0, you can see that we are looking at, right, these two range, where x is less than -2, or when x is larger or equal to 0. Now on the right side, quadratic inequalities, right, whereby the curve is lesser or equals to 0, then we are looking at, right, the region below the x-axis, and therefore the solution is between -2 and 0. Okay, so that's back to our basics inequalities. Right, just draw your graph to help you to identify the range easily. Okay. Now, at the bottom of the page, I've included a mini note over there to remind you that, hey, if this x squared has a coefficient that is the negative value, please remember to do what? If your quadratic coefficient is negative, right? As I divide by negative, I need to remember to do what to the sign? Okay, very good. Please write it down. I want to remember to flip the direction of the sign, right? Just go and change it, and then you can go and solve it as per normal. Okay, so this page is just, reminding us on inequalities concept, and that's about it. Okay, as we move along, the very next thing that we start to learn is on nature of roots. Okay, so can you all please go and circle for me? Under nature of roots, right, there are main two types of questions that can appear. Number one is on finding range, okay, and number two is on proving and showing. Okay, and of course on the left side, I've included some of the great questions in our TYS that I hope by now you all should have completed it. Right, 2015 paper 1 question 4, 2016 paper 2 question 7, 2018 paper 2 question 9. Okay, so these are the main two questions that they like to test under nature of roots, either finding ranges or proving and showing. So let's talk about finding range first. Okay, now in finding range, right, we can either, they can either test us on curve and axis or curve and line. So we take a look at this page first. Find the range of values for which this is always positive for all values of x. So I want to ask you, when the graph is always positive, b squared minus 4ac, what is the answer that we tend to write? When we see positive, we feel like writing what? There's a strong urge, right? Like if positive, then we want to write larger than 0. But can you please remind yourself that is not correct? Okay, that is not correct, right? So can you all let me know in the chat, why is it not larger than 0? How come? Gucci, Xiao, okay, amazing us. Because when we say that the graph is always positive, it means that there are no roots. Okay, it means that there are no roots. Exactly. Right, and therefore, b squared minus 4ac must be less than 0. Yeah, it's floating. Okay, it doesn't cut the x-axis. All right, so it must be less than 0, and therefore we can continue to solve. Over here, right, highlight again. Please remember to flip, right, because I divide by negative. Okay, so all these mini things I want to point out, right, these are the usual mistakes that we make in the exam. Okay, and last but not the least, you notice that we rejected our answer, right? How come need to reject? Why got rejection? Why did we reject a is less than -1? Beautiful, right? Okay, very nice. Because if we want the graph to be positive, a must be larger than 0, right, for me to have a happy face. Exactly, right? So that is something that we want to pay attention to after we solve our inequalities. Go and check, right? Should you be rejecting any solution? Okay, so on the left side of this page, I've already included the mini notes for y'all, right? So all these terms, right, represents how many roots we need to go and remember them, right? Whether it's real roots, imaginary roots, real and equal, real and repeated, distinct, etc., etc., etc. Okay, so that's for curve and axis. Okay, let's scroll down. Thereafter, we also look at curve and line. Now, what's the difference between curve axis and curve line? Right, when we say that the line does not intersect, what's the additional step that we need to do? What's the difference in the steps? Very good. The only extra step, okay, lies with the first step over here, right? Whereby we need to equate, kind of substitute and equate both equations. That's the only extra thing. Thereafter, the whole sequence, right, of how to solve the inequality, just carry on and continue by itself. Okay, so that's just an extra pointer to take note. Now, I purposely included this question for us because I noticed that back in Sec 3 and some of you over here, when you see k squared minus 64, right, some of us, you just remember, okay, in this room, there will be people that tries to square root on both sides. Anyone did something like that before? In Sec 3, whereby if you bring over, then you square root, then you realize, how why my range become like that? Never, okay. So some of you do that. Okay, so this is not correct, right? Because the moment I square root, then we cannot identify the direction now. So therefore, remind yourself that always factorize. Always be factorizing. Okay, don't treat it like an equation whereby you try to bring over, then you square root, then you stuck over there, then you confuse yourself. Okay, so just always factorize, and then you can find your range from there. Okay, so this is on nature of roots, curve and line. So you equate when we are, looking at the intersection between the curve and the line. But on just now, the previous question is just the curve and axis, right? It's curve. Okay. Yeah, plus minus 8 lah. But then the direction, you will be confused lah. So always go by the factorization technique. Okay, so as I mentioned just now, cannot square root inequality. Now, as I mentioned just now, sometimes you have to reject your answer. So I have given you, right? See, I even sourced 3 different variations when to reject. Okay, so first question is I reject the positive value, right? Second one, I reject the negative value. Then the third question, I reject 0. Now, in all these rejection questions, right, there is a pattern. How do we know I need to reject? Okay, come, let me test you. How come sometimes we reject, sometimes don't reject? See the shape. Okay, more specific. Not just the shape. Okay, of course, shape is important lah. Okay. No one. Okay, let me give you a slight clue. Yes, I think Rachel. Yes, Rachel is the most exact one. We typically reject when there's an unknown value for my coefficient of x squared. Go and highlight. We typically reject when the coefficient of the x squared is unknown because that will determine my shape. Okay, so you highlight, right? A lot of times when the coefficient of x squared has an unknown value, then that can change the shape, right? Whether it's positive or negative. Then we want to be careful. And then the rest, if it doesn't has an unknown value for the x squared, then it kind of doesn't affect. Okay. Yes, well done, Rachel. Okay, good job. Okay, so just check the coefficient. Okay, let's carry on. Sometimes we'll encounter proving questions, right, for nature of roots. So there are 2 ways to prove, explain in this topic. So y'all just take note, we have the completing the square method, whereby we need to complete the square. Okay, and thereafter we can explain directly from there. Now, on the right side, we have the deduction method, whereby we break up the equations, right? Okay, and slowly explain, right, that the graph, whether it's larger than 0 or less than 0. Okay, so this is the proving technique, either on completing the square or either through deduction. Okay, so a quick one, 2 examples over here for you all. Okay, please remember, check the key phrase lah, right? The keywords. If it's about explaining, proving, showing, then you need to do through completing the square or deduction. Okay, and never put in the sign at the first step. All right, so that's on proving. Okay, well done. You all are doing fantastic, you are doing great. Okay, so we have completed the first chapter. Let's carry on to certs. Okay, who agrees with me? Out of the entire syllabus, right? Certs is like one of the more easier ones. Agree with me? Easy. Yeah, well, you all every certs, I'll skip lah. 3 marks. Okay, so a quick one. Certs is quite short. There are only a few concepts that we need to know, right? Of course, first of all, we want to learn and remember how to simplify certs. So whatever big value there are, right, we want to simplify the roots. So root 50, you can see I can simplify it to be 5 root 2. Next, second concept, right, is on my expansion. So expansion, right, we can rainbow, we can special products, right? So expand out carefully. Always remember that you can simply take number times number and certs times certs. And finally, right, we have our rationalization concept, whereby we want to rationalize so that our denominator, there's no square root values. I love certs. I also love certs. Okay, so that's all. Only 3 things: simplifying, expansion, and rationalization in this topic. What could be hard? Okay, y'all can just write down. What could be hard is just they link to word problems, whereby mensuration comes in. So you can see I included 2 questions for y'all. When certs is linked to a bit of like mensuration pyramid question and cylinder question. So of course you must remember the formulas of your different shapes lah. Okay, but E-math is just like a few days before A-math, right? So y'all should be more or less clear. Okay, on pyramid. This is like the first question. Typically at the start one. Okay, cylinder, prism, pyramid, cone, all the different shapes lah. Okay, they can test this as well. Okay, so this is rather quite short. I believe all of y'all will not find difficulty in. Okay, well done. Okay, yes, be kind. I don't know why some of you have like some commotion going on. Okay, be focused. Okay, come here to learn and do well for O levels. That's more important. Okay, so next topic, we are moving on to polynomials and partial fraction. So in the entire topic, right, I've summarized neatly. This is the summary for polynomials and partial fraction. So in polynomials, we have our finding unknown value. We have remainder factor theorem. We have formation of original equations. We have solving cubic equation, where we have factorizing cubic equation. Okay, so these are the few important things that we need to take note of in the topic of polynomials. Okay, so as you scroll down, let's quickly take a look at long division. Okay, the order doesn't matter. Okay, let's quickly take a look at long division. There are 2 things that you want to be careful of. Number 1, in long division, please take note of any missing algebra. Okay, so if there's any missing algebra, like you can see, there's a missing 0x over here. I need to account for the 0x. Okay, next, we want to be very careful with the sign, because that is something that we want to be very careful about with the sign. Okay, so these are the 2 things, the missing algebra, okay, as well as the sign. And thereafter, more or less, you all should be okay already. Yeah, just these 2 things. Okay, let's go down. Simple one, to find unknown values, right, we can either expand and compare, or we can substitute. Okay, so both are, easy topics, right, concepts over here. We can either expand and compare the coefficients, or we can do a mini substitution. Okay, so that's the first type of question that they can test on finding unknown value. Okay. Okay, let's go down. Next concept, remainder and factor theorem. Okay, so by now, I think this should be quite easy. So far, when you all are doing TYS question, right, remainder and factor theorem, does it feel quite comfortable? Yes? TYS quite chill, right? Polynomials not hard, right? Yeah, quite chill. Prelim sometimes can be quite weird. I don't know, some of the prelim papers can be quite challenging. But in this topic, so far, the last 10 years, polynomials quite easy one. Prelims hard, but polynomials TYS quite chill. Just remainder, factor theorem, etc. Okay, yeah. Okay, so what is the most challenging in over here, right, in our polynomials is where we need to form polynomials equation. So in some of prelim papers, right, if you go down, you'll notice that they test question like this. Find the remainder when this is divided by x squared minus x minus 2. Okay, so I've looked through some of the prelim papers. Some of our polynomials are like, extremely difficult, where they test you on forming original equation. So can you please put a star over here? Okay, just in case this year TYS or the questions get hard, right? Okay, please take note of this component lah, whereby things can get slightly more challenging. Okay, just put a star, go and prep this before your exams. Okay, so that's on formation of polynomials. Okay, let's scroll down. Fourth question type is on solving polynomials. So solving polynomials is a whole similar process, right? We used our calculator, okay, to find the factor, right? Do long division and then we factorize, okay, and thereafter we can get the answer right there. Okay, if the question asks us to leave in exact form, then this is a clue that we need to use quadratic formula. Okay, so I say again, solving polynomials, the sequence is more or less pretty chill, right? Factor theorem, long division, and then we can solve directly from there. If they ask to leave in exact form, then that is a clue that, hey, you might be, needing to use a quadratic formula. Okay, so everyone okay with solving polynomials? 3, 5 marks, 4 marks, 5 marks for all of us. Okay, if you are clear, please type clear in the chat. Okay, then we move to the next part. Okay, well done. Okay, so what could be hard on solving polynomials is where they bring in different hence questions. So one of the hence question that they can bring in, right, they can bring in nature of roots. So they can tie in two topics, polynomials with nature of roots, and ask you, hey, this cubic equation got how many roots? Right, and that's why you need to bring in your b squared minus 4ac, right, to determine the number of roots there are in this equation. Okay, so that's one possible way they can combine two topics together. Okay. Number two, discriminant, right? Find the number of roots. Number two, sometimes we also see replacement questions, okay, whereby after we solve, they say hence, right? Solve, this new particular equation, right? Or you can see that there's 3 different types of replacement question, right? We can replace first one. I can replace with y minus 1. Number 2, we can replace with 2y. And last but not the least, we can replace with 1 over y. Okay, so these are the 3 replacement questions that we want to take note. Level 1, level 2, and level 3. Okay, so go through these few questions. Okay, next up, under factorizing cubic equation, okay, so we bring back this concept whereby when I want to factorize cubic equation, okay, what's the 4 letters that you see over there? What's the 4 letters? Very factorized. Okay, amazing. We have SOAP. Okay, so what is SOAP? Who wants me to quickly talk about this? Anyone needs like a refresher on SOAP? Okay, so some of you. Okay, so what does SOAP stands for? Very simple. You can see that SOAP here is here to guide us to remember how to factorize. So when I want to factorize x cubed plus y cubed, first and foremost, you can see that the first part is x plus y. So write down same. Okay, S stands for same. S stands for same. Next, O stands for opposite. Because the sign over here is plus, and now this one we got to switch to negative, right? So plus becomes minus. And AP stands for always positive. Always positive. Okay, so let's try it out for the one in the bottom. X cubed minus y cubed, we can see this part. This is the same. Minus becomes plus. So this is opposite. And the last one, always positive. Okay, yeah, so SOAP, well done, John. So this SOAP is there to, guide us, to help us remember, because the sign that's plus minus, right, we will get confused. So it's, it really makes my life easier. Same, always positive. Okay. Okay, that's the first thing. Number two, right? What do you think is another common mistake that we make in cubic equation? What is the second thing that you want to be very careful about? Over here, what does this remind you of? In our special product, in E-math, we have our expansion, right? Right, we learned that x plus y square is x squared plus 2xy plus y squared. So I know, right, many of you over here will have the urge to put a 2 down there, right? Even I have the urge, right? In the past when I was a student, I keep making a mistake because I thought that there's a 2 that we learned from E-math. Okay, so remind yourself that, hey, in our cubic equation over here, SOAP, don't put a 2. Okay? So that's all on cubic equation. If it comes out, it's going to be a 2 marks question. And I've put 2 equations below, right, for you all to just take a look at it. Okay, so this is on our last question type in polynomials. Okay, so once that's done, we are moving to partial fraction. So let's do this together as a class. Step number 1, when I look at a partial fraction question, what should I think about? Okay, first thing up, what should we think about? Okay, amazing. Check whether it's a proper or improper fraction. So what does it mean when I say it's an improper fraction? What does an improper fraction mean? Okay, not just larger, right? Not just larger. So please write this down. The power in the numerator is larger or equal to the power in the denominator. Okay, so there's an equal sign over there. Yes, JVL, well done. Power in the numerator, right? The degree, more specific, right? Is larger or equals to the power in the denominator. So I give you an example. If let's say I have x cubed minus 1 over x cubed plus 2x plus 1. Is this a proper or improper fraction? Okay, give yourself a high five. Okay, well done. Okay, improper fraction. Good job, everyone. Okay, because the powers are the same, so we need to go and do our long division. Okay, good job. Okay, thereafter, before I continue to split, right, I need to take note of this second step, which is to fully factorize the denominator. Why do I purposely include this step? To remind you that I need to factorize the denominator. How come? Why did I purposely put in a step 2 to ask you to fully factorize the denominator? Very good. Okay, please write this down. Sometimes when I see, let's say when I see x plus 1 times x squared minus 4, we have the urge to write a over x plus 1 plus bx plus c over x squared minus 4. Correct, because I see a quadratic factor, x squared, bx plus c lah. This is one of the case, right? Is this correct or wrong? X squared correct, quadratic, right? I see some people agree with me, correct. Okay lah, this is not correct lah. Okay, what we should be doing, right, this is wrong. We should be fully factorizing, right? X plus 2, x minus 2. Then we split up. Okay, then we split up. So you can see there are 3 linear factors, a over x plus 1, b over x plus 2, c over x minus 2. Okay, that's why I purposely include this step to remind you, hey, go and factorize first. Okay, everyone feeling good? If you are good, please type good in the chat. Let me know. Okay. Okay. Okay, thereafter we can split and then we can find our ABCs. Okay. Okay, and that's all on polynomials and partial fraction. Okay, let's carry on. Next topic, we have our exponential topic. So under exponential, okay, this is the summary over here. So in exponential, please take note. First, we look at solving. There are three ways to solve exponential equations. Can you all please type in the chat? PLS. Okay, please. Okay, there are three ways to solve exponential equation, right? P, L, and S. Please. Okay, so what does PLS stands for? Number one, we can compare the power P. Number two, we can sublon on both sides, L. And number three, we can go by substitution, right, which is an S. Okay, so we have P, we have L, and we have S, P, L, S. So go to the next page. Let me quickly walk you through. I have inputted three different variations of PLS, and I want to walk you through. Now, when do we apply comparing powers? P. When do I use P? Okay. When we can create the same base. Please write this down. We use P when the base can all become the same. Amazing. We use P when the base can become the same. Now, when do we use L? We use L when the base now is what? Can it be the same? Can both become 2, 3, 1? Cannot, right? So we use that when this is different, right? Different base. Different base. So then I use L. Now, last one, when doesn't limit, you can use log also. Okay, last one for substitution. When do we use substitution? Okay, please take note. We can make the same term. Same term, right? So 3 to the power of x, there's the same term. So I can replace it with another algebra. So that is our P, L, and S. Same base, different base, same term, right? That tells you which technique to use. Okay, is this helpful? Easy, right? Now you can easily like, same base, okay, P, different AL, same term, S. Okay, that's all lah. Okay, so AMAT becomes super duper easy, like, especially we are doing like a full crash course now. Yeah. Very easy now. See, come for paradigms class. Make life easy for you. Okay. So so that's why y'all come here, right? Okay, so let's carry on. On top of our solving techniques, right? Okay, we have our work problems. So work problems comes out quite a few times. Please take note of these two particular year, 2013 and 2019, right? So these are the 2 years to take note. And in work problems, okay, just highlight, how to explain, in the long run whether it beats a particular equation. So I've given an example over here for you all to take note. Okay, but there's a few questions in the TYS that are quite good to practice. So 2013, 2019, go and try it out. Okay, I have done you a favor. As I'm looking through all the prelim papers, I've seen some of the challenging exponential work problem question. So over here, first one, please put a star. This is slightly harder than the rest. Okay, after the class, go and take a look at it, right? Exponential work problem compounding question. Go and highlight it. Okay, next one, scroll down. This is another challenging question that I've seen. Okay, and I help you all to pull out and so that you all can take note. Okay, not bad. I feel, like it's like me going for exam. Hey, study this, hey, prepare this. Okay, exponential problem. This one challenging. Okay, go and prep. Okay, so these two questions are slightly harder than the usual typical questions. Yeah, both are hard. Both from prelim papers one. Okay, welcome. Okay, so that's all on exponential. So just solving and work problems. Now, as you scroll down, we are looking at logarithms now. So under logarithms, okay, go and get A1. Yes. Okay, under logarithms, there's a few things to take note. We have our simplifying and we have our solving. Log. Lol. Okay, so let's go down to take a look at logarithms first. In school, right, law of logarithms, as we start to learn, it feels a bit confusing because there's so many laws that we need to learn, right? There's so many laws, like 6 and 7 or 8 in our textbook. So I always tell my students, right, hey, just go and categorize them. So in my worldview, right, there's only 3 laws to take note. It's either you can split and combine, right? You can bring down the power, or you can change the base. There's only three important ones. The rest are more or less not that crucial. So these are the 3 important rules that we have to follow. Okay, but let's take a step back first. Why are we learning logarithms? Okay, so I just do a quick review with you all. Logarithms came from indices, whereby 3 to the power of 4 is 81, right? So when I have log 3, 81, what is the answer? Okay, very good. So log 3, 81 is 4, right? So what essentially we are finding? We are finding the power. So that's kind of like the purpose of like log, right? We want to kind of rearrange these indices, right, to find the power. So that's why log 381 is 4. So which means that taking this concept, we bring to the center over here. What is log AA? A to the power of what gives me A? Ah, yes, amazing. 1. And what is log A1? Wow, you're faster than me. Okay. Okay, good job, good job. Okay, 0, A to the power of 0 is 1. Okay. Okay, so these are the basics of log. Okay, and thereafter we have our rules, split and combine, power law, and change base law. Okay, so these are the main 3 things. Okay, will there be breaks? Break is coming up. Okay, after we finish this segment. I understand log now. Okay, we haven't come to the main bulk, the main part. Okay, the main part, as we scroll down, is about solving logarithm. Now, under solving logarithm, we have 3 ways to solve log as well. Okay, y'all don't need break, I need break. I shake. Okay, I talk for 1 hour, I will lose my voice. Okay. Okay. So there's 3 ways to solve logarithms. Okay. Just now was what? What was the technique just now? It was in exponential was P L S, right? Please lah. Okay. Now in logarithms, I haven't figured a creative way to teach this, but we have LCS lah. Okay. Okay. LCS. Okay. LCS, log to index, CCC, and substitution. So these are the three technique. Y'all can help me out, so that the next batch, the juniors, can have a creative way to remember LCS. Okay, but first method is log to indices. When do we use log to indices? When there's 1 log. Okay. Listening completely sucks. Okay, we have 1 log. Okay. Next. CCC and substitution is used when there's many log. Okay. So over here, right, you can see that this can be created into the same base. And over here, we see the same term. Okay, so my job here is just to help you to recognize when to use which technique. Okay, so you have LCS. Log to indices is used when there's only 1 log. CCC is used when there's the same base. And substitution is used when they are same term. Okay, so what does CCC stands for? Okay, I don't think you all know. Okay, only my students know. Now, what does CCC stands for? Now, CCC stands for number 1. When we are solving, right, change the base. Change the base. Please write this down. Change the base. Step 1. Change the base. Step number 2. Right? Once the base are the same, what are we doing over here? What are we doing over here after change base? I'm doing what? Y'all can create for me already. Yes, I'm combining the base. Okay, so that's the second C. Combine the base. Right? Merge, combine the base. Yes. Okay, now once I combine the base, then I can do what? I can do what? Remove, right? Remove the logarithm. So yes, very nice. I cancel the log. So that's the 3 C's. Change the base, combine the base, and cancel the log. Cancel the log. Okay, so that is what CCC stands for. Change base, combine base, cancel log, and thereafter we can find X. This one good. Of course, every slide good. I spent a long time to create this. Okay, so okay, CCC, change base, command base, cancel out. All right. Okay, so that is all on the logarithms segment. Okay, let's carry on. Now, how many of you face difficulty in, you can use either, doesn't matter. Okay, next, we talk about logarithm graph and exponential graph. Okay, so can I check who here struggles to remember the shape of the graph? I will skip this question. Don't know how to check. That's graph. Okay, so let me teach you a powerful technique to remember the graph. Okay, very simply. Okay, come, let's take a look at your palms over here. Okay, come, you all go and see your palm, right? Your hand ugly. Okay, come see your palm. Now, the shape of the exponential graph and the logarithm graph, right, lies on your hands. Okay, I say again, the shape of your exponential graph and your logarithm graph takes the shape of your hand. So, let's see over here. Come, you see your right palm first. Now, your right palm, okay, this line over here represents e to the power of x. Okay, I think this is like the relationship line. Okay, e to the power of x. Then that's your relationship. Okay. Okay, over here. Okay, this is e to the power of x. Then at the bottom, okay, I think this is your lifeline. Okay, lifeline. Okay, see how long you're gonna live, right? Whereby, okay, this line represents ln x. Ln x. Your lifeline damn long. Okay, I hope you live until 100 years old. Okay. How I find this out, I was on the bed thinking about how to remember this. And then I look at my hand. My hand got lines. I realized it can. Okay, now on the left side, come, let's take a look at your left hand now. Left hand, you can see exponential, right? E to the power of negative x. So that is e to the power of negative x going up. Okay. Okay, it's going down, kind of going down. Okay. Okay, next below, right? We have ln negative x. Okay, ln negative x. Okay, so on the palm, okay, we have e to the power of x, ln x, e to the power of minus x, ln minus x. Okay. Your left palm like straight. Okay. Hey, is this helpful? If yes, please type yes in the chat. Zai or not? Very useful, right? That helped me a lot also. Okay, yeah. Okay, e to the power of x, ln x, e to the power minus x, and ln minus x. Okay, so use your palms to remember. Yeah, right side and left side. Yeah, okay, can. Okay, so that's on exponential. High five you. Okay, high five you. Give you a fist bump. Okay, let's carry on. Next we have binomial theorem. Okay, under binomial theorem, we have two main types of question, which is our binomial expansion and finding specific term. Okay, so under binomial expansion, on the top left-hand side, there are a few important rules to follow. Number one, it is, okay, please always remember to put in a sign. Okay, sign. Number two, for powers. And number three, please remember to add in the plus dot dot dot. Okay, so these are the three things to remember when you're doing your binomial expansion. Okay, the sign, the powers, and the plus dot dot dot. All right. Okay, so I've included two questions over here for you all, right? One is selective expansion. One is full expansion. So selective expansion comes in when they ask for a specific value, just an x. Okay, just an x value. Full expansion comes in when they ask you to find many terms, right? Like the first few terms. Okay. So 32 minus hx plus 2hx squared. Okay. Hey, Royce and K, why y'all like bootlicking me? Y'all better get A1 for A math, okay? Okay, 32 minus hx plus 2hx squared. Okay, so over here, go and find your few terms over here. Selective expansion and full expansion. Okay, and of course, I've included two other ways they can apply binomial expansion, right? Which is our replacement question. We can replace with a number or we can replace with algebra. Okay, so a few questions here to take note on all the different types of binomial expansion question. Okay, so we have our selective expansion, full expansion, and then replacement questions. Okay, so just run through these examples after class. Okay, these are the few things to look at. Okay, next, we have finding specific term, right? So this is a common one. I think more of us face difficulty in finding specific value, right? So please take note of the entire flow, the steps, how to find the specific value, how to compare the powers. So I've listed an easy question over here on the left, and then the challenging question on the right side. Okay, so pay attention to this part. This is the one that is typically more challenging lah. Okay, so finding specific term. Okay. Okay, now I want to ask you our next question. Okay, do y'all know in binomial expansion, this topic, right? Okay. Many prelim papers have been predicting this one type of question. Okay, I don't know how many of you have looked through all the prelim papers, but as I'm looking through, so many schools are predicting this one type. Anyone knows what type of question are they predicting? Anyone want to take a guess? Independent, no, not independent. Yes. Okay. Unknown power. Please take note. Unknown power. Right. So in the next page, I've listed down 2 questions with unknown power for y'all. Okay. Do y'all know why many schools predicted unknown power? Because in the last 10 years, take a look at TYS. Tested before or not? In the last 10 years, have you done any unknown power before? Never, ever, ever, right? Don't have. Yeah, don't have. So many schools this time around, right, are like, hey, let's spot unknown power might potentially come out. So many of prelim papers actually test unknown power. Yeah, so your schools are predicting as well, lah, right? They want to make sure that you're prepared. Okay, but I'm not sure how many school teacher will tell you that, lah. Okay, but I'm here telling you that many schools are predicting it because in the last 10 years, 2009, that's super far already. Last 10 years, 2013 to 2022. You can see JY said come out in 2009. That's how long ago? Okay, that's like a dinosaur already. Okay, that's like my time of O levels. Okay, so please go and prep unknown power binomial. Can everyone? Okay, promise after the class, take the next few days, right? Go and try out unknown power. Can? Promise? Okay, just in case it comes out. Can. Okay, go and practice. In case 5-6 marks comes out, I want y'all to get that marks. Okay. Yeah, don't worry. We only got 500 people over here. A lot of people taking AMF in the whole nation. Okay, they're like 20,000, 30,000. Okay, so your benefit can really. Okay, let's carry on. Okay, in coordinate geometry summary. Okay, in the coordinate geometry paper over here, these are all the formulas that you need to take note of, right? Perpendicular bisector, collinear line, okay, shoelace method, right? And then angle between the line and the axis. Okay, so these are all the concepts that I put out. I don't have any specific question I want to go through. Okay, but I want you all to highlight the 2017 paper 2 question 9. Okay, so go and highlight and redo the question 2017 paper 2 question 9. So this is slightly weirder and harder lah. Okay. Okay, and of course, go and remember all your shoelace technique. Angle. Over here, I think many of you never really studied this before. Okay, so when there's an angle and a line, right, remember that gradient is equals to rise over run. Okay, rise over run, which is the same as opposite over adjacent. Okay, opposite over adjacent. And what is opposite over adjacent? What is opposite over adjacent? It's tangent, right? It's tangent, yes. Gradient is tangent. So which means that if I want to find the angle, right, we can simply inverse tangent to find the angle, right? We can just tangent inverse to find the gradient, to find the angle. Okay, so this is just a reminder. Reagan, no, don't need to use. Not allowed, like don't have to use. Okay. Okay, so this is on coordinate um, geometry. How do I know it's a tangent? Because opposite, you can see, it's a bit like opposite and adjacent, right? So if I want to find the angle, I can use that. So there's this formula whereby tangent theta is the gradient. Yes. You can see already, right? Yeah. Okay. Okay, so I think two of the TOS question, you see, I put over here for you. Go and prep this 2017 paper 2 question 9 and 2019 paper 1 question 9. Okay. Yeah. So over here, please go and practice these two questions again. Okay, how to explain the parallel lines and then finding P. Okay, so these two questions over here. Okay, let's continue scroll down. Next, let's take a look at circles. So circles is one of the topic that most of us find difficulty in, right? Okay, so definitely this is another topic that we want to pay attention to. Okay, so basics of circles, right? How to form your equation, how to find your center and radius through completing the square. Okay, so I say again, one thing to practice, right? Make sure that you are strong and you are comfortable with finding the center and the radius. Okay. Hey, I'm curious. There's so many people over here. Can I do a market research? How many of you learn the formula, like this shortcut method? How many of you use completing a square? Okay, so I ask again. Those that learn completing the square, type 1. Those that learn this like G and FC1, type 2. I don't. Oh, okay. So, okay, 70% is 1. Okay, 70% is 1. Okay. So most of us learn completing the square. Only some schools teach you the G square, F square, and C the shortcut. Okay, yeah, most of you is 1. Okay, so under circles, right, how to do well in circles? Okay, on first glance, we feel that circles, there's a lot of variety of question. Okay, but to be frank, there's only these few types of questions over here. Okay, hey, I asked finish already, carry on already. Why are still replying? Okay, we have position of coordinates, we have reflection about line, and then we have tangent chords and perpendicular bisector. So these are the main few questions that they test us in circles. Find the position, reflection, as well as tangent chords and perpendicular bisector. Okay, which I've listed here for you. Okay, so I want to ask you, okay, out of all these in the past 10 years in your TYS, which one has yet to be tested? Which one has yet to be tested? Position of coordinates, reflections, tangent, chords, perpendicular, bisector. Which one have yet to be tested? What concept haven't tested before in the last 10 years? Okay. Very good. Can you please put a star over here? Number 1. Reflection questions has yet to be tested. Okay. And take note, reflection, we can reflect about vertical line, we can reflect about horizontal line, and can reflect about diagonal line. Okay, so go and practice all the different variations of vertical line, horizontal line, and diagonal line. Okay. Next, what else? What else has yet to be tested? Tangent come out before? Yes or no? Tangent normal. Tangent normal have seen before. Many times, right? Like I think like 5 times. Okay. Yeah, tangent very popular. Okay, but perpendicular chords and perpendicular bisector has yet to be tested as well. Okay, so go and focus on chords and bisectors. Tangent normal is the most common in the last 10 years. Okay, but reflection question and then bisector and chords are not really tested before. Okay. So these are the main 2 things to take note over here. All right. And of course, we have our 2015 paper 2 question 7. Okay. So 2015 paper 2 question 7, right? Okay. What came out was the circle was leaning on the axis. Anyone remember this question? The circle is leaning on the axis. 2015 came out. A lot of people cannot do. Cannot see before. Okay, so go and prep this. Okay, 2015 paper 2 question 7. Okay, but I've listed down over here already. Number 1, for chords, tell yourself all perpendicular bisector passes through the center. Okay, all perpendicular bisector passes through the center. Number 2, all the normal, right, also passes through the center. Okay. Nabila, just sub in x is 0. If you get y is 0, then it passes through origin. Okay, so chords, tangent, normal, and axis. This one never test before, so put a star over here. Never test before. Yeah, reflection also never test before. Yeah, go and take note of it. Okay. Next one, linear law. So linear law, standard questions, right? The full flow to linearize, find the new coordinates, plot, find A and B, solve the remaining equations. Okay, so go and take note of the question here. Okay, so linear law is a giveaway lah, right? Linearize, find new coordinates, plot, find A and B. Okay, so I hope linear law, you are expecting it to come out and then you are able to get out the answer. All right. Adriana, see the table. You can follow the values. How long should we spend on linear law? How long should we spend on linear law? At max 15 minutes. Okay, best to time yourself is 10 minutes. Okay, means maximum you cannot spend more than 15 minutes. But if you can push yourself, right, train to push to 10 minutes, that would be ideal. Okay, so this is on linear law. Okay, let's carry on. Over here, we are moving on to plane geometry before we take a short break. So plane geometry, I have consolidated all the important formulas that you need to know, right? So we have the circle properties, right? We have circle properties over here. We have angle property, right? We have congruency and similarity tests, right? We have midpoint theorem and we have alternate segment theorem. Okay, so these are the main few things to take note. Okay, so yesterday, who was in my E-math class again? Okay, what method did I teach you all to remember the angle property? Okay, we start easy first. We wow the rest. Okay, what is the angle property? We learn what? Okay, thank you very much, everyone. Okay, so we have VICA. So everyone, the rest write down. VICA, VICA, vertically opposite angle, interior angle, corresponding angle, and alternate angle. Okay, so VICA for the angle properties. Okay, next. Hey, yesterday, don't let me down. We have went through the 5 circle properties. What is that sentence that we learned, okay, about Mr. Tan to remember these 5 circle properties? Okay, what about Mr. Tan? What is the sentence? Okay, our Mr. Tan is here. Okay. Yes, Mr. Tan, yes. Okay, so please write this down. Mr. Tan loves 2 times 90 equals to 180 degree. Mr. Tan loves 2 times 90 equals to 180 degree. All right. So each of these represents, a key property. Tan represents tangent. 2 represents, right, angle at the center twice the angle at circumference. 90 is about semicircle. Equal is about equal segment. And 180 degrees for the cyclic chord. So these are the main 5 properties. All right. Okay, and of course, over here we have our congruency and similarity test that we walked through yesterday. Okay, and in A-math, just 2 properties. We have our midpoint theorem. So midpoint theorem, right, basically just tells me that if D is in the center of AB, and if E is in the center of AC, then we can conclude that, number 1, DE is parallel to BC. Okay, I say again, if the question tells me that D and E is in the center of AB and AC, then I can conclude that DE is parallel to BC. That's number 1. Number 2, I can also confirm that the ratio of DE to BC is 1:2. So these are the 2 information that we can get. DE to BC is 1:2. Okay. And DE is parallel to BC. Okay, Mr. Tan, repeat Mr. Tan. Okay, so the keyword over here, right? Mr. Tan loves 2 times 90 equal 180. So Tan is for over here, right? Tangent perpendicular to radius. 2 times is for angle at the center is twice the angle at circumference. 90 is here. Angle at a semicircle is 90. Equal is for same segment. And last one, 180 degree is for cyclic chord. Okay, so Mr. Tan loves 2 times 90 equals 180 degrees. Okay. Okay. Midpoint theorem doesn't come out much, right? Because the midpoint theorem is not very it doesn't have a lot of information. Okay, so I say one more time. The question first must tell you that D and E is in the middle of AB and AC. Okay, you must know that. The question must say. From there, you can make two conclusions. Number one, DE is parallel to BC. And number two, DE equals to half BC. Okay, so these are the two conclusion. Ratio theorem is not in syllabus already. In my time, 10 years ago, yes, okay, but now no more already. Okay. So the ratio to DE to BC is 1:2. Okay, because you can see that it's similar. The moment they are similar, can you see the triangle? They are all similar already. So 1:2, 1:2, 1:2. So the base also 1:2. Yeah. Okay. Next, you have alternate segment theorem, right? So if you have a tangent and a triangle, so make sure the triangle touches all the sides. Then if they are pointing in the same direction, the angles are the same. Yeah, well done, Lavanya. Okay, pointing in the same direction, the angles are the same. Okay, now I have another gift for you. Okay, I have another gift for you. In our entire plane geometry, right? Who here struggles in plane geometry? Like generally, like you find it quite hard in DYS and all. Okay, so scroll to the next page. I've really helped you all so much. Okay, there are only 5 main types of plane geometry questions that you'll encounter. Okay, number one is the bisect question, right? Whereby angle, they're equal, proof isosceles, okay, or it bisects. Now, if this comes out, you're either gonna be using alternate segment theorem or circle properties. Okay, one of it. Number two, if you are proving that lines are parallel to one another, you need to either use midpoint theorem or your angle properties. Okay, only these two. Next, congruency and similar triangle. This one is our EMATH context. Okay. Okay. Thereafter, we have our multiplication question. This one is testing us on similar ratio, right? Forming your fraction. Okay. And last but not the least, this one is the hardest. Okay. And it came out twice in 2014 paper 2 question 6 and in 2017 paper 1 question 10. Okay. Okay, so these are the only 5 main types of questions that you'll see. Okay, won't see anything else really. Either prove isosceles, prove the same angle, prove they're parallel, congruency, similar triangle. Then you see some multiplication thing, then you know it's a similar triangle question. And then last one is some weird one. When you see like 90, 180, then you know it's hard already. Okay, then twice came out, right? 2014 and 2017. I start cause like take note it's hard okay. Okay, so these are the main 5 types over here. Okay, so everyone, midpoint theorem. Midpoint theorem is basically I can explain that parallel Okay, I can parallel. Just when D and E is in the middle of AB and AC, then they are parallel. Okay. Okay, so we are halfway through the syllabus. We are almost like halfway Next one is Trigo already. Hey, can I check first hour? Has it been useful for you? Learn a lot of things or not? Okay, I breathless already. Okay, so before we take a break, okay, let me share with you. Okay, PowerPoint. Who wants the cheat sheet? Okay, I spent a lot of time for you. Okay, just do me a quick favor. Right, during the break, okay, you can follow us on Paradigm's account. Take some quick shot, right? Share your experience, right? What was your experience? Okay, people typed a long chunk yesterday, saying that they have a lot of good grade takeaways from the class. Okay, then after that, once you are done during the break, right? Okay, do me a favor. Okay, can you all, right? If you haven't get never mind, later you'll just fill up the notes. Okay, if you haven't get, right, very simple. Everyone go with me to this link. Okay, go with me to this link. Okay, come on, let me show you. You all go and click that link. Okay, so in this link, right, this is how we're gonna send you the cheat sheet. Everyone click to this link. Okay, type in your name, your WhatsApp number. Don't type wrongly, so that we later send to the wrong person. Okay, pin your WhatsApp number. Okay, and then over here, if you have tagged us and shared and you want to redeem the cheat sheet, just click over here lah. Okay, and then put in your IG account for us to verify. Okay, so over here, just click yes. Then if you don't have IG, just get your friends to help you and send it over. Okay, so help me put the IG handle. Now in the last segment, okay, over here, if you have siblings and juniors that want to join us, for holidays and next year, and you want to know like some of the referral benefits that we are giving you, just tick yes also. Some of you want to go JC next year, right? And you're interested to know more about our JC classes after your results are out. Okay, you can click on that. And last but not the least, if the classes has been useful, and from the bottom of my heart, right, if you want to say thank you and you want to write a thank you message, right, okay, then help us to put a tick here as well. Okay, then you can just submit. So those that have yet to receive your eMath cheat sheet, right, after we send you, right, because once you submit the form, we will have your number, man. So you just tell my team member, hey, you haven't sent me the eMath cheat sheet. Clear? Okay, so don't lie, okay, you tag them, we can check also. So if you have yet to receive your eMath, okay, key in again, and then we will send you the eMath cheat sheet. And thereafter, just let us know that you want the eMath cheat sheet as well. Okay. Okay. Then, okay, once done with the form, type done in the chat. If IG account private, should be able to see. Yeah, should be able to see. Yeah. Yeah, should be able to see. No worries. Okay, so as long as you tag, we can check on that. Okay. Then just tick. Okay, you can tick more than one over here. Then after that, just submit. Okay, the rest, once done, let me know. The link I sent again over here. Short one. Okay, just don't pin your WhatsApp number wrongly. Okay, type correct. Okay, if not, I cannot send you. Okay. Okay, one last time. Those that are done, let me know. Then we take a short break. Yeah, must tell you lor. Okay, can. Okay, let's take a 5-minute short break before we continue to trigger differentiation and integration. Okay, go and chill for a while. Thank you. Okay, once I'm back, please type back in the chat. Dun, 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 dun. Okay, Sri Gwen, awesome. Okay, so we have 35 more minutes. Okay, let's try to finish the remaining segment. Okay, so the next topic that we are looking at. Okay, what's the next topic? Okay, I don't know, is it a love-hate relationship with this? Now, the next topic that we are looking at, okay, is, it says trigonometry. Okay, so under trigonometry, there are a few things that we want to take note of. So in this entire summary, okay, we have simplifying question, we have graph, we have quadrants, we have proving and solving, and thereafter we have our R formula. Okay, so this is the types of questions that will be tested in the exam: simplifying, graph, quadrants, proving and showing, and R formula. Okay, so first one is on simplifying, right? So few things to take note. Number one, remember all your special angles. Okay, number two, when it comes to simplifying, certs and rationalization will come in quite often. Okay, so number one is on special angles. Number two is certs. Okay, and thereafter number three, we can always press our calculator to check our answer. Okay, we can always press our calculator to check the answer. So just take note of these three things. Replace with our special angles, certs, and then we can press our calculator to get the answer. So two questions to take note, 2014 and 2018. These are slightly harder. Okay, I think this is paper 2 lah. Okay, 2014 and 2018. Okay, go and look through these two questions again. Okay, now let's scroll down. Next concept is on principal value. So principal value, it only come out once in 2016 paper 1 question 3. Okay, but all we need to do is just to remember the range of values. Okay, so in tangent, for sine, and for cosine. Okay, so what does principal value means? Anyone knows or not? Need to go through? You know what's principal value or not? My cher never teach before. Okay, so principal value, right, is basically the set of values that covers all your y values. Okay, so you can see for sine, right, here is -1, here is 1. From minus 90 to 90 degrees, it covers my entire range of y values from -1 to 1. It covers everything. So therefore, we say that for sine, right, the principal value is -90 to 90 degrees. Okay, so that's for sine. Now you look at cosine. For cosine, 0 to 180 degrees, okay, cover the entire set of y values, right, from 1 to -1. So we say that the principal value for cosine is 0 to 180 degree. Okay, and lastly, for tangent, right, from -90 to 90, you can see it covers all my y values, right, from -infinity to infinity. So we say that the principal value, like the main values, right, come from -90 to 90. Everyone can see? So this, because the rest are repeat, the rest are just a cycle repeat. So just this range of values, right, cover all my y values. Okay. So 0 over here. So we are looking at the main one. 0 to 180 covers the first set. Then the rest are just repeat. All the same are repeat. So just this means set of values. So for sine is -90 to 90. For cosine is 0 to 180. For tangent is -90 to 90. Okay, so these are the first main set. Then the rest are just a repeat. Okay, so if it comes out, it's just a 1-2 marks question. It came out in 2016, paper 1, question 3. Okay, so you'll just look at it. Okay, thereafter, principal values, we move on to quadrant questions. Okay, so quadrant questions, how many of you have seen this type of question in your prelims or your WAs before? In many of the papers, right, quadrant, find a quadrant, label, right? But do you know that it only came out once in 2019 paper 1 question 1. Okay, it only came out once in 2019 paper 1 question 1. So therefore, please pay attention to this, right? Especially when they test on like half angle formula, double angle addition, right? So these are more complicated questions that we want to pay attention to, right? This year. Okay, so half angle, double angle, all these are part of the syllabus. Okay, and because it only came out once like in 2019 paper 1 question 1. Okay, can. How do I know it's a half angle? The question is like that one. You see, cosine b over 2. Cosine b over 2, sine a over 2. Yeah, so the formula for the half angle is written over here for you already. Okay, I've helped you all by listing down the roots. Then you just need to put in the cosine in your value of cosine. Okay, so I have listed one example for you already over here, part 3. Okay, so after the class, you'll just go and take a look at this question over here. Okay, then double angle is easy lah. Double angle just put in only 2 sine A cosine A. Okay, so I repeat one more time. Quadrant question, the last time it came out is 2019 paper 1 question 1. Okay, so I feel that this is something that's important lah for us to take note, just in case it comes out this year. Half angle, double angle, etc. Okay, next, we have our trigo graph, whereby we need to sketch our graph equations, how to draw a sine wave, cosine wave, and tangent wave. Okay, so there are 3 things that I want to share with you all under this segment. Number 1, if this is my graph equation, okay, what is my amplitude? If this is my graph equation, what is my amplitude? See, I know that's a trick question, right? What is it? -2 or 2? Okay, please type it down. Amplitude must be strictly positive, right? So it should be strictly 2, not -2. Amplitude is a positive value, so just 2. Okay. Second thing to take note, let's say I have sine x over 2 plus 3. Okay, my period is 360 over 2 is 180 degrees. Is this correct or wrong? 2 divided by 2. 180 lah. Wrong, right? Yes. Okay, so second mistake that we must avoid is that this must be half. This must be half, right? Because this is half itself. So the answer will be 720 degrees. Amazing, huh? Okay, so that's the second thing to take note. Number 3. Okay, third thing to take note over here lies with our tangent wave. So a normal tangent wave, right? Do you agree with me that tangent wave we find quite challenging for most of us? Sine, cosine is still quite chill, right? Tangent is usually like the most confusing one. Right. Okay, so I teach you all how to draw tangent wave easily. Okay, now tangent wave, very simply, always start from the back. Always start from the back and then curve up. Okay, so that's the first thing that you should be drawing, right? Start from the back, from negative infinity, curve up. From here, the period is 180 degrees. Then I label the coordinates. So follow the sequence, make life easy for you. Right, -90 to 90, right? Thereafter, we just repeat the entire cycle. Okay, so another 180 degrees. So this will be 270. Then you repeat. Okay, so make it easy for you. Start from the back, right? So the mistake that we see commonly is people confused, right? Then they start to draw funny things like this. Okay, funny things like this. Then this is wrong. Okay, if period change, then you change your period lah. Okay, you're going to change your values. Okay, but the whole idea is start from the back and shoot up. Okay, then that will be very helpful. Okay, follow the domain. They always tell you where to draw. Is it 0 to 360? Is it -180 to 180? Okay, then you will be able to get the answer. Abdul, so draw your curve first. Then thereafter, you'll know where is your symbol. Okay, always go and draw your curve, then you can figure out the asymptotes easily. Okay. Okay, so your one more example, is it? Okay, I give you one more example. If let's say we look at y equals to tangent 2x. So tangent 2x, right? What's the period? What's the period if it's tangent 2x? 180 degree divided by 2, right? Which is 90 degree. Okay? So the question will always tell you, hey, I want you to draw from minus 90 degree, right, to maybe 90 degrees. So when I draw, you can see that always start from the back. Okay, start from the back. Okay, what should I label over here? Knowing that the period is 90. Knowing that the period is 90 degree, what should I label over here? Can you see? Now it's easy to draw, right? Minus 45 and 45. Okay. Then thereafter, you just need to draw one more, right? Because we need to stop at 90. Then over here, I start at minus 90. So I kind of know from here that these are my asymptotes. Okay. Easy. So that's all for tangent. Tangent is 180. Yeah, tangent is 180. Sine and cosine is 360. So tangent is special. It is 180. Okay. Okay. Yes, thanks, Nabila. Yeah, tangent no amplitude. If negative, then just flip. Okay. If it's negative, then flip. Okay. So in our trigo, there are two challenging graph questions that I've listed over here for you. So this came out in 2019, paper 1, question 12. Okay, and 2017 paper 2 question 10. So one of it is find the number of solutions. Okay, and number 2, right, is how many of you have seen this question, the y1 larger than y2, or like y1 minus y2 larger than 0? The 2017 question. Okay, so I've helped you all. See, I help you all again. Okay, by this page, these are the two hard trigo questions that you must prep. Okay, so left side, number of solutions, draw your line, find the number of solutions. On the right side, okay, we have our y1 and y2, right? Whereby we want to find the range over there. Okay, so look at these two questions specifically, 2019 and 2017. Okay, these two are harder questions that high chance of being tested. Okay, next, as we scroll down, another challenging trigo questions is where we deal with application. So application, I've also put in two questions for you all to go and try it out. It came out in 2016, paper 1, question 11. So trigo graph are slightly harder, right? Where we want to apply the question, right, to find the ABCs and to solve. Okay, so can you all please put a star over here? After class, right, go and practice this specifically. Okay, so that's trigo graph. Okay, let's continue. Next, we have proving, right? Priestley, so after you draw the graph, right, to find the range where, let's say, y1 is less than y2, you can see that we are looking at the range over here. Because this part, right, the y1 curve is below y2. So we are looking at the graph, right, to determine who is on top of one another, right? They are looking for the range of values whereby y1 is below y2. So you can see that over here, the y1, this part is below the curve. Yeah, y1 is less than y2. So my solution, it is starting from here to here and from here to here. Yeah, so just draw your graph and you can find the range from there. Okay, and of course, look at 2017 question again. Okay, so that's on this. Okay, okay, next we have proving question. Proving question, I've consolidated some proving questions for you all if you want more practices. Okay, so on the left, I have the simple ones. This is more TYS standard. Okay, TYS standard is on the left. This is more like prelim standard. So I've consolidated prelim standard on the right, which is a lot tougher. Okay, which is a lot tougher. Okay, so proving on the left, simple one, TY standard on the right is more challenging questions for you to try out. And I've also helped you out by just listing down the main formulas so that you don't have to flip and refer. Okay, this can be your notes to study for your exams. Okay, so that's about proving trigo. Okay, thereafter, we look at solving trigo. Okay, so these are the basic ones. Now, I want to quickly run through. For solving trigo, there's a framework that we can follow together as a class. So can you please type in the chat BQDB? BQDB. BQDB. Yes, BQDB. So BQDB, right? We can use that. Okay. Hey, why so little people? We got like 500 people here. Where are the rest? BQDB. Okay, please type in BQDB. Yes. Okay, so what does BQDB stands for? B stands for finding the basic angle. When you are finding the basic angle, take note, number one, always positive. And number two, you need to check whether it's in degree or in radian. Okay? Always positive or degree or radian. Q stands for quadrant. D stands for change the domain. And B stands for bracket. Okay, so this is the 4 steps to follow when you are cannot be negative one. Okay, yeah. Yes. Thanks for helping. Okay. BQDB, right? Basic angle, quadrant, domains, and brackets. Sounds good, everyone? Okay, let's continue. Our formula over here, yes, okay. Bracket means you can see that we are solving at this moment, right? When we solve, we need to solve the bracket first, which is 2x plus 60. Now, some of us have a common mistake whereby we just jump to x. Okay, but we are solving 2x plus 60 first, then we find the x. Yeah, so you see from this side, we can label step number 1, B. Okay, quadrant is positive, right? So here is quadrant. Number 3, change the domain. And number 4, right, solve for the brackets. So BQDB. Okay, BQDB. Basic angle, quadrant, domains, and bracket. All right. Okay, next we have our formula. So our formula, okay, few things to take note. Number 1, okay, please write this down. For our formula, always find more right angle triangles. Okay, always find more right angle triangles. Domain is the range of answers that they ask you to find. Usually it's like 0 to 360. Then, but we need to adjust at times. Yeah. Okay, our formula, find more 90 degrees. Okay. Nabila, thanks. Okay, number 2, find more theta. Okay. Then we use Tuakaso. Find more right angle, find more theta, and then we use Tuakaso. So over here, you can see, never cut the angle. Okay, never cut the angle. Because once you cut the angle, you cannot use Tuakaso anymore. The angle changed already. So always cut the right angle over here. Okay, once you cut the right angle, you can see that this is 90 minus theta, and this is theta. Okay, over here, always cut the angle, and this theta. Yeah, cannot use Tuakaso anymore already. Okay, so always cut right angle. Then you can easily find more angles, right, to use our Tuakaso. Okay, so that's on our formula. Okay, and one particular you to take note is 2017, paper 2, question 11. Okay, 2017, paper 2, question 11 is very hard. Okay, let's carry on. Okay, so that's all on our formula. Okay, moving on. Differentiation. Now, under differentiation, this is the entire summary. Okay, we are moving the last pillar already. Okay, differentiation and integration. Okay, yeah. So under differentiation, at the top, we have our simple chain rule, product rule, and quotient rule. Okay, chain rule, product rule, and quotient rule. Applications, we have equation of tangent normal, increasing, decreasing function, rate of change, and maxima, minima. And then at the bottom, right, we can have trigo, exponential, and logarithms. Okay, trigo, exponential, and logarithms application. So start from the first one, right? The hardest is about trigo, exponential, and log. So when we are differentiating trigo, okay, number one, please take note, we can only differentiate sine, cosine, and, okay, help me change this to tangent. Okay, we can only differentiate sine, cosine, and tangent. Okay, number two, can you all type in the chat PTB? Okay, PTB. PTB. Okay, so when you are differentiating trigo, right, follow this sequence. Power, trigo, bracket. Power, trigo, bracket, right? So bring down the power, power minus 1. Differentiate the trigo, differentiate the bracket, right? So PTB. Okay, so P, settle the power first, differentiate the trigo, differentiate the bracket. Okay, PTB. Yeah, so follow this sequence. You can get it ready. Okay, so that's for trigo. Two things to take note. Okay, next. Exponential, right? Differentiate the power, right? Multiply by the original. So take note of exponential. And of course, the harder one is law of indices, whereby over here, please don't use product rule. Over here, please don't use quotient rule. Okay, don't make your life so easily so hard Okay, so okay. Okay, next we have our ln. So law of logarithms, right? Differentiate the bracket over the original bracket. Okay, and you can see the harder questions. Okay, please bring down your power. And here you can speed up. Okay. For exponential, you can write down number one, differentiate the power multiply by original equation. Differentiate the power times original equation. Yeah. Okay, so that's on differentiation. Okay. John, that will be a hands question lah. Okay, or if not, you rainbow expand out if it's possible. Yeah, but you won't see those kind of product rule question in integration. Okay. Next, differentiation, increasing, decreasing function, right? I have split up over here for you already. 2015, 2020, 2013, right, is finding unknown values. Number two, on the right side, we have explanation proving question, 2011, 2016, and 2021. Okay, so split up and go and take note of how to solve finding unknown value questions or proving questions. Okay, so these are the two variation right here. Now, in increasing, decreasing function, right, I want to help you all to take note. Please read the question carefully, right? Are they asking where the curve is an increasing, decreasing function? Or are they asking that the gradient of the curve is an increasing, decreasing function? So if they're asking about the curve, we are looking at dy dx, right? Whether it's larger than 0 or less than 0. Ahmed, Ken. When we are looking at gradient of the curve, we are looking at the 2y dx square is larger than 0 or less than 0. Okay, so these are the two things. Please be careful of the phrasing. Okay, if you all take note, can please type clear in the chat. Important, okay, for our O levels. Curve is increasing or gradient of the curve is increasing. Two different things. Okay. So for explanation, same thing back to nature of roots, right? Whether it's completing the square or deduction. Okay, so it's a bit like nature of roots, like prove that it has two roots, right? Okay, so you must explain directly from there. Okay, thereafter, so I've given an example over here, like. Okay, so really, you can see this example of an explanation question, right? Whereby this is deduction method. right? I look at the fraction and then I slowly explain to them, right? Hey, the denominator confirm larger than 0. Hey, I numerator over a positive number, right? You can see negative 17 divided by a positive number confirm negative. So therefore, this value will be a negative value. The gradient is a decreasing function. So deduction means step by step, break up the equation, right? And then explain, hey, this one confirm positive. Hey, this one confirm negative, right? Then the whole thing confirm negative. So this is deduction. Yeah. All right. Thereafter, rate of change. Who agrees with me that rate of change is like the hardest, like one of the hardest thing? Like, not me. Okay. Usually like hard lah. Okay. Okay. I think it's hard lah. Okay. So I've listed just go and do every question lah. Okay. 2011, 2016, 2018, 2019, 2020. I just go and do everything. Okay. So generally there are 3 rate of change questions: split and cancel, double split, and mensuration. So go and take note of all these different variations under rate of change. Yeah, okay, so go and try out all these questions over here. Okay, next. At the bottom, right, we have maxima, minima. So we have the first test and the second test. Okay, so first test and second test. So table and the 2i dx square method. So under maxima, minima, right, we have our mensuration and curve. So this one is the easy type of question lah. Correct me. If it comes out this, then find nature of roots, right? Like we all celebrate, right? Yeah, so easy. Easy lah, okay. Okay, but when it moves to the right side of mensuration, sometimes we face some difficulty in proving and finding the nature of roots. Okay, so please take note over here. 2011, 2013. I just go and do every year lah. Okay, proving, right? Then after that, go and solve. All these are more complex questions. Hard. Rate means harder. Okay, rate means harder. So just take note. Okay, so we have graph and if you don't have 2011, then just check out. Okay. Okay, moving on to the final last topic. We are on to the last one already. Integration. Last one, okay, before we go and rest. No water. Finish already. Last topic, integration. Okay, over here. Okay, so at the top, we have our indefinite and definite integral. And of course, we can apply it to trigo, exponential, and logarithm. Okay, from here, applications of integration, we can take a look at curve, area under the curve, and kinematics. So I just slot kinematics over here in this segment. So this is the entire summary of integration topic. Okay, integration, trigo, exponential, log, and then all the different ways to apply integration. Okay, so number 1, please go to the next page. Okay, and remind yourself, there is no product rule, there is no quotient rule in integration. Okay, there is no product rule and there's no quotient rule in integration. So you need to go and simplify the equation. Okay, so over here, you can see I can go and simplify, right? And simplify. Here we can simplify. This is 4. Okay, we can simplify. Okay, so you can see over here is just pure simplifying. No product rule, no quotient rule. Okay, and last one is 5, 3x minus 7 minus half. Okay, this one easy, right? You see, after you simplify, then you realize that actually the question not as hard. So simple one. Okay, but you do quotient rule, and then you confuse yourself, then become hard already. Okay, amazing. Okay, so that's on product rule and quotient rule. Next, thereafter, we have our integration for trigo, exponential, and logarithm. Okay, so over here, trigo, take note, we can only integrate sine, cosine, and secant squared. Okay, we can only integrate sine, cosine, and secant squared. Okay, you all want to Okay, I go back a while. Okay, we can only integrate sine, cosine, and secant square. Okay, once done with this page, please type done, then we move on together. Okay. Okay. So we can only integrate sine, cosine, and secant square, which means that if they give me other fanciful equation, like 1 over cosine square, tangent square, sine square, cosine square, we need to go and change using our identities, right? Go and change. So 1 over cosine square, we change to secant square. Tangent square, right, we change to secant square minus 1. Sine square and cosine square, we use our double angle, right, go and change. So you can see change. Okay, to get our identities out. Then we can integrate from there. Substitution, no, you won't be done. JC concept already. Okay, next. We then move on to exponential and logarithm. So exponential, simply divide by the coefficient, right, of the power. Okay, and then a logarithm is simply right, changing back to a fraction. Okay, so what I want to point out, right, is in the next page. Okay, next page more important. Now, this is something that we want to be very mindful about. When you are integrating fraction, please take note, if my denominator is linear, okay, this is a Lorentz integration. Okay, this is a Lorentz integration. If my denominator is a algebra, right, you can see a quadratic, right, with a power, there's a power. Okay, then this will be an algebra integration. Okay, so quickly highlight over here, this forms back to ln 2x minus 1. This, you can see, instead of ln, I will bring up, right, my denominator. Okay, power plus 1 divided by new power and the bracket plus c. Okay, so please be careful, right, of these two difference. Then cannot lie. Brian cannot. Yeah, so take note of the differences. Okay, so usually this comes out in, no, it's not 2 ln, it's just ln only, right? Because in our differentiation, ln 2x minus 1 gives me 2 over 2x minus 1. Okay, so when I U-turn back, it's just ln. Yeah, because the numerator is already 2. If it's like 1, then you need to adjust. Yeah. You take the 2 out, then you put it in. Yeah, troublesome. Okay. Yeah. If, okay, in another world, right? Okay, so in the separate event, if I want to integrate this, right, then I need to top up a 2, right? Outside, I need to divide a 2. Then this one will give me half ln 2x minus 1 plus c. This is in another scenario. Yeah. Okay, so we need to adjust lah. Make sure the numerator is the coefficient of your x in the denominator. Then you'll be fine already. Okay, so just take note of this over here. Okay, we are gonna reach 10. Hey, can I get your permission? Shall we extend like around more? We are ending soon already, like 10 more minutes, can? Or end now. And now I sayonara, I go and rest. Okay, just one more, okay? 5, 10 more minutes. Okay. Okay, so that's on log and algebra. Okay, next, let's continue. We have definite integral. Can you please put a star over here? Okay, can you please put a star over here? All of us have seen this back in our homework questions, right? Back in WA1, right? But prelims like TYs never see before, right? So can you please put a star just in case it comes out? Don't forget about this. This still exists is in our syllabus. Okay, so take note of definite integral questions over here. This one is in our textbook one. In WA1, WA2, it comes out, but we haven't been seeing this for a while already. So I want to prompt you. Please take note in case it get tested this year. Okay, so over here, differentiation and integration hands question. That's the next one to take note. 2015, 2018. Okay, go and do the questions one more time. Because hands questions are usually quite tough. Right, so some of the hands questions like 2015, 2018 are slightly tougher than the rest. Okay, so please take note over here. Okay, carry on. Equation of curve. Okay, if this question comes out, we should all celebrate. I hope it comes out. This is quite easy, right? They all agree with me. The 2y dx squared, then we u-turn back to dy dx, then we u-turn back to y. Then we celebrate, I'll celebrate. Okay, but I just want to caution you all, 2019 paper 2 question 5, they come out a 9 marks question over here. Okay, 2019 paper 2 question 5, it came out a 9 marks question here. So this is easy, but it's not tiring. Okay, it's not very long. So go and do again 2019 paper 2. So it looks easy like just need to integrate twice, right? And then go and find your unknown values. Okay, then you can show it. But it takes a while. It's 9 marks. Okay, so while it's easy, must leave in exact. So please be careful of this. Okay. Next we have area under the curve. So I've already go and listed down all the questions. This one basically just do everything lah. Okay, there's nothing to avoid. Just do everything. 2011 down to 2020, I just do everything. Okay. 2015 is slightly a bit weirder and like tougher. So just take a look at 2015 paper 1 question 12. Okay. No formula lah. It's just cutting long. It's just like cutting, right? Then basic shapes, then cutting. Come on. Yeah. So generally it's not very challenging. It's just that quite hard to, you cannot check your work. So the way to master this is to do more questions like, right? Go and cut, then go and subtract. Okay, go and cut, right? Then add up, then subtract. Okay, so all these are our area and graph question. Okay, so if it's below the x-axis, please remember to put in a negative sign, right? Because your answer will be a negative value. So just take note of the notes over here. Okay, but more importantly, right? Next page. Have you all seen area under the graph y-axis question before? Hey, I'm curious, prelims who tested on this? Anyone can let me know? Prelims who tested on y-axis? Are there a lot of people or just a few? So okay, a few lah. Yeah, a few of you. Okay, so take note, if I'm integrating with respect to y-axis, please go and make x the subject. Okay, please go and make x the subject. I cannot even remember. Please go and make x the subject. Okay, next. Over here, can we integrate ln x in our syllabus? Can we integrate ln x in our syllabus? Okay, we cannot integrate ln x in our syllabus. So therefore, we need to change this as well. To make x the subject. Then I can integrate to find the area. So these are the two important questions that I want you all to take note for area under the graph y-axis. Okay? Area under the graph. Nice, understand. Okay, easy. See? Make your life easy. You only got two types only. Make x the subject or ln question. Okay, so only these two things to take. Yeah. Easy. Okay. I hope you are more confident after today's class. Yeah, I changed back to indices. Correct. Okay, so last one is on kinematics. So kinematics, there are main 7 questions to go through, right? Finding velocity, finding acceleration, value of t at instantaneous rest, okay, distance of particle, minimum maximum velocity, total distance, average speed. So there are main 7 questions that they can ask you on for kinematics. Okay, and as usual, every question I would go through lah and go and redo the questions. Okay. Okay, but there are several hard questions in kinematics that we want to take note of. Okay, so 3 scenarios. Number 1, 2 vehicle question. Number 2, starting point is not at origin. And number 3, 2 regions. So these are the 3 hard kinematics question, right? That I have pointed out. 2 vehicles question, starting point not at origin, and 2 regions. So in the next page, I already listed down all the important ones. So first and foremost, find the distance traveled in the 5th second versus find the distance traveled in 5 seconds. Different, right? 5th second is from 4 to 5 seconds. In the first 5 seconds is 0 to 5 seconds. So you can see that these are 2 different techniques. Okay, that we need to take note of, 4 to 5 seconds and 0 to 5 seconds. Okay, can you all see? If you are clear, please type clear in the chat. 5th second is 4 to 5. Travel in 5 seconds is like first 5 seconds, right? 2 different things. Okay. Yeah. Okay. Now let's take a look at 3 hard questions. Okay, so over here, number 1, we have displacement, right, which is on the left. Okay, displacement which is on the left. Okay, so take note over here, 3 meters to the left. Number 2, second question to take note is the kinematics questions, right, whereby there are 2 particles that collided with one another. Okay, so take note over here. You can see that the starting point is not 0. The starting point is not 0. It's at the left side. Okay, so displacement is, when time is 0, displacement is -3. Over here, take note of 2 particles banging together. I don't think many of you have seen this question. Okay, but this is something to take note when 2 particles knock into one another. Okay, and the last one is a TYS question for 2017 paper 1 question 9. Okay, 2017 paper 1 question 9, whereby there's 2 regions, 2 different formulas in our kinematics. So these are the 3 hard questions to look at. Okay. For the particles colliding one, right, it just means that, you see, particle A, right, has its own displacement formula. Particle B has its own displacement formula. The point where they bang to one another, where they collide, is where the displacement of A is the same as the displacement of B. Cause means, you know, like playing catching, like you run, this me, this you started run first, right? Then I tap you at one point, right? I tap you, means the distance that we cover is the same. Right, so that is where I equate both displacements together to find the time where I catch you. Yeah, so something to take note. Okay, 2 particles question. Okay, so one more time, displacement not at 0, 2 particles question, and 2 regions question. Okay, can? Okay, and hey, congrats! We have completed the full syllabus from first topic, completing the square, down to kinematics. Okay, we have completed everything already. Okay, hey, how was today's session? Oh, okay, tired. Yay, congrats. Okay, so few things, right? Who wants the cheat sheet or have yet to tag, right? Just a reminder, right? If you go and follow us, share, take photo, right? Take some photo and tag it on your IG, right? Later, the team will send you over there. Okay, and then those that have yet to fill up the form, right? Remember, you all must fill up the form, then we can send you the cheat sheet. Okay, so I run through again with you all. Over here, in the form, right? okay, in the form. Remember to key in your name, put in the correct WhatsApp number, okay, and then yeah, cheat sheet, IG story, and then sorry, IG handle. Okay, and then over here, right, if you have siblings and juniors that want to join us for class next year and you want to know more about the referrals, you can just tick over here. You want to go join us for JC classes, tick over here. And then if you want to say thank you and drop us a thank you review, right, then tick over here. Okay, send the link again. So must click in, if not, we cannot send you the cheat sheet. Okay. Okay, so do me a favor, show off the shark. You want to see the shark and the dolphin? The shark here. Okay. Okay, hey, can y'all do me a favor? Hey, do me a favor. Okay. Um, can y'all type one sentence, right, about today's class? I just want to get some feedback. How was today's class? Was it useful, beneficial, 10 upon 10, 8 upon 10, 5 upon 10? Okay, hey, can y'all help me? Okay, so that we can get more people to join us next time, right? Okay, so go to your, take our phone, right? Go to Telegram. Okay, how was today's crash course? Okay, go to our Telegram channel, right? Do me a favor. Can just drop some comments over here. Okay, just help me to drop some comments and share your feedback, lah, so that more people can join us in our crash course in the future. Okay. Okay, can type longer also, lah. Can type longer also. Okay. Come take out phone.